priority for these problems is to solve for y. So you need y to be by itself and in y equals mx plus b form so that you can graph your line. So in order to do that, in that first example, you have to move over the 2x and then divide by -1. You could also add the y and add the 1 and then just sort of flip the problem. So you do the way that works for you. I'll do the way I think a majority of us will do. And then we'll see if you get down to the same answer. Okay. So you should get y equals 2x minus 1. Or plus 1, sorry. Is that what you're going to ask me? Yeah. All right. Plus 1 is my... So that's where you start the graph. Oh, I totally forgot there was like a big thing. What is my slope? Perfect. So my y-intercept is 1. My slope is 2. So I go up 2 over 1, up 2 over 1, up 2 over 1. Or down 2, left 1, down 2, left 1. Now what makes these ones a little bit trickier is usually I tell you guys, you only need like 3 points. For this one, your first graph, you need to get like as many points as possible so that you can see the point of intersection on the graph. So these ones, the graph needing to be straight matters a little bit more. So that's my equation for line 1. For line 2, going to solve for y. Ignore. So you get y equals -5 x minus 8. So my y-intercept is -8. And then my slope is -5 over 2. So we're going to go in reverse and go up 5 and left 2. And what you'll notice is that these two graphs intersect at the point -2, -3. And that's why graphing your line so straight is so important. So it says the solution to the graph is it's x, comma, y. -2, -3. X, comma, y. It is the point on the graph where the two lines hit each other. So these are what type of lines? They have how many solutions? And it is what type of system? Perfect. Yes, do make it now. Okay, example number 2. Same idea. And again, if you didn't see it from the graph, you could also see it from your equations, right? Are the slopes the same? No. So different slopes tell you that they're going to be intersecting. So then at that point, you know when you graph it, you need to make sure you graph carefully. Number 2, subtract 3x from both sides. So you get 2y equals negative 3x minus 2. Divide both sides by 2. So you get negative 3 over 2x minus 1. So 2 divided by 2 is 1. It's negative. It stays negative. My slope is negative. So I'm going to plot my y-intercept at negative 1. And then I'm going to apply my slope of negative 3 over 2. So you're going to go down 3 and over 2. Or up 3 and left 2. Connect your points. And there's my graph. Graph your second line. So once again, you need to solve for y. So you add 4x to both sides. Oh, you can't. And divide by 5. What makes this graph kind of stinkier than any of the other graphs we've looked at today? Is 28/5 a nice y-intercept? No. So if that happens, instead of a y-intercept, I could start my graph where? Not a y-intercept, but an x-intercept. How do you find the x-intercept? Perfect. So the x-intercept occurs when y equals 0. So if I plug y equals 0 into this equation, you get negative 4x equals negative 28. So x equals what? 7. Now, what does that mean? That means that when this graph hits the x-axis, it's at 7. Because this is the x-intercept. The x-intercept is the point on the x-axis. What's the slope of this line? So you can apply that slope at any point on the line. It does not have to be at the y-intercept. We just always teach you the y-intercept because it's usually a point you can easily see. But technically, any point on this graph is a valid point to start your slope from. So we're going to start the slope from the y, not the y, just kidding, the x-intercept. So you're going to go up 4 and over 5 to the right. But that takes me off my graph. So instead of going up 4 and to the right 5, you can go, yes. Oh, I picked the big dot. 1, 2, 3, 4. 1, 2, 3, 4. Boom. So what happens when I go down 4 and left 5? I intersect my other graph. So my solution is that point of intersection. So in this case, they intersect at x equals, perfect. The point of intersection is 2, negative 4. That is my solution. Yes. So what did you do? The only problem with that Yeah. Because technically the answer is 5.6. What happens is that, like, since we're looking for such specific points on the graph and the solution and the point of intersection, graphing it from 5.6 puts you, like, off whole numbers. So, like, did you get to -4 for your point of intersection, like, perfectly? Okay. It just leaves room for error. Does that make sense?
Like if you get like 3.15, yeah,
like your decimals and stuff. It just leaves room for error. You did not see that. Oh, teeny tiny. Don't move. Man. Give me 2 seconds to finish these 2 examples because you missed the lesson yesterday, and these are different from the previous. All right, number 3, you have -x plus 4y equals 20, and you have -4x plus 2y equals -10. So same rule as always, solve for y. So you add 8x, and then we're going to divide by 4. So my y-intercept is a positive 5. And my slope is up 2 and over 1, or down 2 and left 1. Connect your points to get your line. Okay? And then we're going to do the same thing for the second equation. Add 4, divide by 2. So you get 2y equals positive 4x minus 10, or y equals 2x minus 5. So now my y-intercepts are different, but my slope is the same. So this goes through -5 and up 2 and over 1. Which means that if these lines continue forever and ever and ever and ever, they will never intersect. Therefore, because they are parallel lines and they never intersect, what is my solution? No solution. So you could do like the little circle with the line through it. That stands for no solution. So it says the solution to the graph is no solution. Or you can be like me and write out all the words. So I want to practice writing on my board. And number 4, we're all super duper happy because number 4's first equation is y equals mx plus b. So we plot our y-intercept, go down 3 and over 1. Those of you that are faster than me, you could do it on paper. I already hear you rustling. You know my answer. And then for the second equation, you're going to divide everything by 2. And what happens when I divide everything by 2? It's the same. So now my lines sit on top of each other. So if the lines sit on top of each other, how many points do they have in common? Yeah, every point on that line is in common with it. So how many solutions does it have? Yeah, too many to count. So, concluding paragraph. Your homework is the next page in your packet. Front and back. You have the remainder of class time. I'll be around to help you. Questions, comments, concerns? Wonderful. You may, or well, not you may use the